All right, now I want to talk about Dalton's law of partial pressures. This is if you have more than one gas inside of a container. So up until now, we've been talking about single gas systems. What happens if you have two or more gases? All right, and basically the law is very simple. It's the sum of the individual gases. Okay, so you can see here the total pressure is the sum of the individual gases, or what they call partial pressures. So if you take the pressure of this gas, P1, which is, I don't know, let's just say it's 2 atmospheres. Okay, see this is kind of 1, 2. And then the pressure of P2, which is 3 atmospheres. And if you combine them into one container, the pressure now is 5 atmospheres. It's the sum of the partial pressures. That's all it is. Okay, so you basically have, you're basically going to have probably a problem to figure out the pressure of this gas, and then you'll have a second problem to figure out the pressure of this gas, and then you'll add them together to get your total pressure. That's basically a classic problem. So you can see here I have one vessel that has this many moles of nitrogen and 0.118 of hydrogen at this temperature. What's the partial pressure? All right, this is an ideal gas law. I have my V, I got my temperature, I got my moles. You solve for P for nitrogen, you solve for P of hydrogen, two different problems, and then you sum them up. Okay, pretty straightforward. I'm going to let you kind of work this on your own, just to kind of do it. So what you're doing is you're going to have two different equations. PV equals nRT for your nitrogen gas, and PV equals nRT for your hydrogen gas. All right, your pressure for both of them is going to be the same pressure, all right, which is what you're solving for. Sorry, you're solving for those. Your volumes is 1 liter because both gases are in a 1 liter container. Your moles for nitrogen is 0.215. Your moles for hydrogen is 0.0118. Your R's, remember, 0.0821. And then your temperature is 25 degrees Kelvin. All right, I'm sorry, 25 degrees Celsius, which you have to convert to Kelvin. You're going to solve for each pressure, whatever they are, and then you add them up, and that is your total pressure. Okay, and so go ahead and try it. Here it kind of works it out for you. It's pretty straightforward. Okay, so that is it for this chapter. Pretty straightforward chapter, and like always, if you have any questions, please come to them and we'll talk about them in class.